Let's take care of some geometry examples that we had mentioned in our summary packet. Going in order, we've got first to find the complement and supplement of 28 degrees. The complement refers to two angles that will add up to 90 degrees. So we have the complementary angle plus the 28 degrees equaling the 90 degrees. That means that we would need to subtract on both sides. So if we subtract 28 degrees on both sides, that will give us an angle of 62 degrees. For the supplement, we again have two angles that have to add up, but this time those two angles have to add up to 180 degrees. So we've got a different variable marker for that. Y plus 28 degrees is equal to 180 degrees. Once again, we've got to subtract the 28 degrees. So doing that on both sides will get us our supplementary angle, which would end up being 152 degrees. Our next example uses the relationships between angles where we have our parallel lines and our transversal. So we have one angle that is given. Out of the 8 that appear, we have one that's given, and we are asked to find all of the other angle measures in the diagram, which we can do even though we've only got one measurement. We have enough different kinds of relationships that we can accomplish this. We've got several ways to start, but to hit a few of the different options, well, not a few of the different options, all of the different options for how these different sorts of angles relate to one another, I've got a plan in mind to illustrate some of the ways that we can find those different angle measures. Starting with the 131 degrees has this angle that we can bring up the transversal to hit angle 2, and that's what we're talking about when we talk about corresponding angles. So angle 2 is going to be that 131 degrees that we have showing up based on corresponding angles. Then we can take angle 2 and we can bounce it to angle 4. Those are vertical angles. Vertical angles are equal. So angle 4 is equal to angle 2 because of vertical angles. And we know that angle 2 is 131 degrees. Then, again, just to show some variety here, angle 2 is exterior, angle 6 is exterior, and it is opposite, on opposite sides of that transversal. So alternate exterior angles. Angle 6 has to match up with angle 2, which again we know is 131 degrees. Now let's mix it up a little bit. We've got several of the angles up top. We've got angles down here on the bottom. Angle 5 and angle 7 down here on the bottom are missing. Let's go ahead and throw in that idea of supplement that we were just using a moment ago. If we've got the 131 degrees and angle 5 adding up to 180 degrees, that straight angle as it's called alternately, then angle 5 can be calculated based on 180 degrees minus 131 degrees, giving us angle 5 is equal to 49 degrees. And then immediately from there, vertical angles tell us angle 5 and angle 7 are equal. So angle 7 is 49 degrees. Based on, just again to throw in some of that variety, based on angle 5 and, well, no, I'm sorry, we're not ready for that. We're going with angle 1. Angle 1 is listed as another supplement calculation there. Got ahead of myself. So angle 1 coming from either angle 2 or angle 4. Just to mix it up, let's use angle 4. So 180 degrees minus angle 4, which we know is the 131 degrees, so that we're getting angle 1 is 49 degrees. And then angle 3, here's what I was thinking of just a moment ago. We've got angle 3, we've got angle 5. These are interior. They're on opposite sides of that transversal. So angle 3 and angle 5 are alternate interior angles. Alternate interior angles are equal. So angle 3 is equal to angle 5, and angle 5 we have as 49 degrees. Speaking of degrees, we've got that notion of a circle, we've got circumference, we've got arc length. So there's this relationship, this proportion relationship. The angle that we have that is a portion of the inside of that circle over top of the total angle for the circle, which is 360 degrees, has this ratio correspondence with the arc length over top of the circumference. So the arc length between an angle, you have that arc length, the part of the circle, like the pie crust, versus the circumference, which is the pie crust around the entire circle. We are looking to find the circumference of a circle where we have a 100-degree central angle. We have an arc length of 68 centimeters. So we've got the angle, the central angle, 100 degrees. We've got the arc length, 68 centimeters. We're looking for that circumference. So let's put those specific values into that proportion equation. 100 degrees over top of 360 degrees is equal to 68 centimeters over top of the circumference. In order to solve for the circumference, we're going to want to cross multiply to get started so that we can, in a moment, gain access to the C for circumference. So cross multiply, we're going to take the 100 times the C, and then the other half of that cross shape is the 360 times the 68. Notice that I'm leaving off reading those units. I'm leaving off reading the degrees and the centimeters, but I am going to put those into my written work to keep track of what is going on and to make sure that I don't lose track of anything along the way. Now we are in a position where we can get that circumference, C, by itself by dividing. If we wanted to, we could also just go ahead and we could say with the degree symbol on the left and the degree symbol on the right, those can be removed. And the 360 times the 68 would give us 24,480. We cannot remove the centimeters measurement, but we can get that C for circumference by itself if we divide on both sides by 100. So if we take 24,480 centimeters, divide by 100, then this will give us our final value for the circumference, 244.8. We don't need the extra 0 at the end. So that is in centimeters. We want to make sure we remember our units of measurement. So final answer that our circumference is the 244.8 centimeters. Obviously, that's not the only result that we have that's related to circles, so we'll see eventually in our other examples somewhere in here more business about circles. This is just the result that ties in angles and arc length and circumference. Doing a little bit with our polygons. If we have to find the sum of the interior angles of a regular octagon and give the measure of each interior angle, an octagon has 8 sides because, like octopus, 8 is that number coming from that prefix. So we have in our result 180 degrees times the number of sides minus 2. The number of sides for the octagon is 8. 8 minus 2 is going to give us 6. So we want to take 180 degrees times 6 in order to get that sum of the interior angles. That ends up being 1080 degrees, or for the skateboarders and snowboarders, etc. of you, a 1080. Because they also ask us for the measure of each interior angle, then that is going to come from the fact that of the total 1080 degrees, we have 8 angles. They are all the same because we are told this is a regular octagon, and that means that we will have each of the angles. So if you went out with a protractor to a stop sign, you should measure that each angle of that stop sign is 135 degrees. Now for a little bit more ratio stuff, like our example that had the arc length and the circumference business, we've got an old school way of being able to measure things based on ratios and similar triangles. If we want to find the height of a tree that casts a 100-foot shadow at the same time of day that a 5'6" person casts an 8-foot shadow, these are things that we can measure. We know how tall we are. We can have somebody help us measure our shadow. Between two people, we can measure out the shadow length for a tree, and therefore we could say, oh, okay, that calculation, that tree is so many feet tall, and that might be important as far as, hey, I want to climb a tree that's going to be tall enough, or cut down a tree that's going to be tall enough, or whatever sort of purpose you might have for measuring a tree, because maybe you're just bored. Who knows? Now, we can pick a ratio that uses tree information on the top or tree information on the bottom, but since we want to find the height of the tree, let's just try to make things a little bit nicer on ourselves by having that unknown height for the tree on the top. And so the person, we need the height immediately below that, so the 5'6". The tree information also still needs to appear on top when we talk about the length of our shadow, so that would be a 100-foot shadow over top of the person having an 8-foot shadow. Now the height of the person is not a very convenient one. However, we did have this work out to be a little bit on the nicer side for us, because 5'6" is 5.5 feet, 5.5 feet. So transforming that equation into a nicer sort of appearance, over on the right-hand side, we can also ditch those units of feet, because those are no longer necessary. Feet over feet reduce out. Because of the way that we set this up, we only have to do half of the cross multiplication work. If we multiply by the 5.5 feet, then that gives us the h by itself. So 5.5 feet times the 100 over 8 can get us the value that we need for the height of that tree, which as it happens would work out to be 68.75 feet. And let me go ahead and pause here and do the other examples in a separate video